Hi guys. So in this video, I'll be discussing about how can you calculate the diagonal sum of a matrix. Okay. So you will be given with one matrix and you need to calculate a diagonal sum. Okay. Left as well as right. Total diagonal sum I want. How can we calculate? So let's see that. So let me share my screen once. Okay. So diagonal sum means what I mean. So let's suppose it's 3 cross 3 matrix. Let's suppose I'm taking 4 cross 4 matrix for you. Okay. I'm taking the element 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 4, 0. Let's suppose I'm taking these elements, okay? And these are rows 0, 1, 2, 0, and one more we need to do, like it's 4 cross 4. So one more I need to take here. It's 4, 0, 5, 1. Okay, any element you can take of your choice. So now if you want to know the sum of the diagonals, how can you do? So it's 0, 1, 2, 3, and it's 3. Okay. So let me do it properly here. Okay. So here it's total 4 cross 4. So now if I want to know the sum of the diagonals, then how will you calculate? You will simply add this part and this part. Right? And you will get the sum of the diagonals. Right? Will you get or not? Yes, you will get it. So what will be the sum now? So sum will be 6 plus 4, 10 plus 2, 12 plus 8 plus 2 plus 7. Okay. So 8 plus 2, 10 plus 7 is 17. So total will be 29. Okay. So how it is getting calculated? That we will see here. Okay. So first we will consider left diagonal. So for left diagonal, what we will see? We will see the position of that particular element in this 2D array. Okay. So for considering the position, let's understand. So this is 0, 0. Okay. This is 1, 1. This is 2, 2. And this is 3, 3. So this is for left diagonal. And for right diagonal, it is, this one is 0, 3. This is 1, 2. Correct? This one is 2, 1. And this one is 3, 0. So now can you see some pattern between left and right diagonals? For left diagonal, you can see like 0, 0, 1, 1, 2, 2, 3, 3. What you can guess from here? You can guess, right? I and J both are same. So if I is equal to J, that means you will get to know that these are left diagonal elements. And what will be the condition for right diagonal elements? If you say it's 0, 3, here it is 1, 2, here it is 2, 1, here it is 3, 0. Can you guess certain pattern between these four positions? Can you guess certain pattern? 0, 3, 1, 2, 2, 1, 3, 0. Any pattern can you guess? Yes. So if you see like it's a 4 cross 4 matrix. Okay. So if I do matrix dot length minus 1, what it will be? Matrix dot length will be number of rows. That means 4. And if I do 4 minus 1, it will be 3. Correct? So if you do the sum of these two, 0 plus 3, is it matching with this 3? Yes. 1 plus 2, is it matching with this 3? Yes. 2 plus 1, is it matching with this 3? Yes. 3 plus 0, is it matching with this 3? Yes. So yes, now I got the pattern between left and right diagonals. So for printing left diagonal, what we have to do? Same thing which we did for matrix representation, like we will run two for loops, one representing row, I represents row, J represents column, and then within that we will write one if condition. What if condition I will write here? Simply I will write here if I is equal to J. Okay, before two for loops I will initialize one sum variable. Okay, I need to calculate sum, right? In sum equal to 0, and we will be doing this addition within the if condition. Okay, after that if condition gets satisfied. So first two for loops I will write here. First for loop is for running for row, and second for loop will be running for column. Okay, first for loop will go for row, second for loop will go for column. Then within that I am doing if condition. So you can understand these two for loops, right? I'm not repeating it again. It will save time, right? So directly I'm writing the condition. If I equal to j means it will go for left diagonal. Okay, if I don't write this condition, all elements will get added. So we need to skip all other elements, and I will be focusing on diagonal elements only. So for left diagonal, it will be I equal to j, and then for right diagonal means 0 plus 3, 1 plus 2, 2 plus 1, 3 plus 0. That means I plus j should be equal to what? Total matrix dot length minus 1. That is number of rows minus 1, because index is starting from 0. So I will write here matrix dot length minus 1. This condition I have to write. And within that, what operator should I put here? Both conditions should get satisfied. Okay. But we need to print the sum of all. We need to consider as well all the diagonal elements. So if I put and here, it will only consider the middle part, but I don't want the middle part only. We don't want the middle element. Okay. So here we have to consider all the elements. So I will put or. Two pipe operation we have to write, two pipe. So pipe means or operation, and double ampersand means and operation. So this now become the condition for diagonal. So within this I will write sum plus equal to, that means sum equal to sum plus matrix of I and j. Within that it is closed. So like that we will be writing this. So this bracket is for second for loop, and this bracket is for outer for loop, that is for row. Okay, so like that we can print. So rest all the conditions will be same. All those which we have written for matrix representation, same will be done for diagonal sum as well. So let's suppose I want to know what's the middle element, then this or should be replaced with and. Okay, let's suppose I want to know what's the intersection of two diagonal. So it's like it's an even numbered, right? And an m both are even numbered. So there will be no middle element here. Okay, so can you find any element which satisfy both the condition? Like the sum will be equal to 3, okay, and I should be equal to j. Can you find that element here? That means the intersection of those two diagonals. Okay, it will be seen in odd numbered matrix like 3 cross 3, 5 cross 5, 7 cross 7. Okay, but for even numbered, you can't see any middle element. Here you can see it's vacant, right? You can't see that. I equal to j means, let's suppose 2 equal to 2, and I want I plus j should be equal to matrix dot length minus 1. Matrix dot length is 4. 4 minus 1 is 3. See, it's not satisfying. Okay, if you see 0 plus 0 will not be satisfying. 1 equal to 1, and 1 plus 1, 2. 2 is not equal to 3. Okay, and if I consider 3 equal to 3, okay, and then this condition is satisfied or not? 3 plus 3 is 6, and 6 is equal to 4 minus 1, 3. No, that means you can't find any intersecting point in case of 4 cross 4. That means any even numbered n cross m matrix where n and m both are same for this condition. So for any even numbered n cross n matrix, you can't see any intersecting point for diagonal. Okay, but you will get the intersecting point only for odd numbered n cross n matrix. So let me show you with an example. So if I consider 3 cross 3, you will get the idea. Okay, if I see like 0, 1, 2, 4, 5, 6, 7, 8, 9. It's a 3 cross 3 matrix. It's a odd numbered matrix. So here you will see the intersecting point 0, 5, 9 and 2, 5, 7. So if you want to print the intersecting point of the diagonals, so first you have to check whether the matrix is odd numbered matrix or even numbered rows matrix. Okay, So first you have to check the matrix dot length. So if matrix dot length is coming as even numbered, then you just have to print there is no intersecting point for diagonal. But if matrix dot length is coming as odd numbered element like 3, 5, 7, 9, then you can print the intersecting point of the diagonal by putting here and ampersand ampersand you have to put here, and you will get the intersecting point for diagonal. You get it, right? So like this we can implement it. So let's jump onto the code and let's see how it will be implemented through code. Okay, so I'm stopping my screen here. Let me share my main screen. Okay, so first what will I take here? I will take here matrix equal to new int. I will be taking here 3 cross 3 matrix. Okay, then I'm taking here row. Row is matrix dot length. Then I'm taking column here. Column is matrix of 0 dot length. Then what will be my next step? My next step is we have already calculated here. If you see in matrix representation, I have already calculated how to calculate how to fetch the data from the user and how to print. So can we directly use this? It's of static type. So we can directly access it through class name, right? So I will directly access through class name, matrix representation dot, here you can see I can access it directly. So here I am passing matrix. Here is the row. Here is the column. Okay. And what is this part? This part is expecting the input from the user. Okay. So here we need to give data. User will give the data here. Okay. So to give the data from the user, I will write scanner class here. I will give scanner in equal to new scanner system dot in. Okay. So this in scanner class reference will be passing it here. So if I give like this, it will automatically fetch the data from the user and it will print it as well. So it's a benefit, like it's a reusability. So this is the advantage with Java. Then what we will do? Now I'm having that matrix now. Now I have to calculate the diagonal sum. So I'm creating one method here, diagonal sum. So what I will pass here, I will pass the matrix, I will pass n, I will pass m. Okay. And I don't need to pass in because it's already given to me. So I don't need to fetch anything from the user now. So I will create one method here. It's private type. You can change it to public default, anything you want. So here what I will do, I need to calculate a sum. So first I will write 2 for loops, one for row and one for column. So for in I equal to 0, I less than n, and represent row. Okay. Then I will write one for loop for column, j equal to 0, j less than m, j plus plus. Okay, then within that, what I will do? I will check within the matrix if I equal to j or not. First, that we will check for left diagonal. So we will do I equal to j or not. Okay. So this will be coming under one bracket. That means it's for left diagonal. Then or what I will check now? I will check whether I plus j is equal to matrix dot length minus 1 or not. So one more condition I have to check here. I have to check here if I plus j is equal to matrix dot length minus 1 or not. If this condition gets satisfied, then I need to calculate a sum. So I am defining one sum variable here. Okay. And then I will do sum plus equal to, that means sum equal to sum plus matrix of I and j. Okay. So after this, it will be calculating the sum. Then outside the for loop, we can directly print diagonal sum is, we can print this. It's done for you. Okay. So if I run this code, So here it is asking enter elements of 3 cross 3 array matrix. So it's going through the same code, okay, which we have written already. I've not written it again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So here it has created. Now if you see the sum of the diagonals, 9 plus 5 plus 1, it's 15 plus 7 plus 3, 10. 15 plus 10 is 25. It's coming properly. So like this way, we can calculate the sum of the diagonal elements of a given matrix. Okay. So these two elements are very much important. So only if I do one change, it will become the solution of one more question like intersecting point of diagonal. Okay. If I change it to ampersand, ampersand, it will give like, it will be true only in one scenario when I and j both are equal and I plus j equal to matrix dot length minus 1. So it will be only one element. So that will be the intersecting point. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Here you can see intersecting point is 5. So now it's a homework for you. You have to check for even numbered matrix what is coming as a diagonal element, intersecting of a diagonal element. So that you have to do it as a homework. Okay. And try to practice this one through dry run first. First you need to do dry run, then you will get the idea like how it is working together. So I hope you got the clarity how it is working. And it's very much simple. It's very much easy. If you do it once, it will be very much simple for you to understand. So I hope you have understood the problem statement and the whole concept as well. So we'll see you in the next lecture, in the next set of problems. Till then, bye-bye.